Okay guys, so we are going to start off in your spiral. Go ahead and take a minute, get out your own sheet of paper. We will get to the packet that you picked up here in just a couple minutes. We're going to work one problem in your spiral, then switch to that paper. So what we are talking about today is average value. I'm going to give you the definition first. Okay, for an integratable function, okay, f of x, the average value over a to b is given by, okay, and then this is a formula that you are going to use when you need average value. So it's 1 over b minus a integral a to b f of x dx. Now, hopefully yesterday you understood how to find this. Okay, we just learned how to do that yesterday, so really this is the only new part. Now, the first thing that I want to point out to you is what we are finding. Okay, this is the formula for the average value or the average y value. Okay, so here's what that means. Okay, we're going to go ahead and do one example in your notebook, then we'll switch to that other paper. If you are finding, let's say, the average value of the function, let's do y equals 3x squared on the interval from, we'll do -1 to 2. Okay, so first let's just find it. Okay, so pretty straightforward. You're going to do this formula right here. So 1 over b minus a is going to be 1 over average value equals 1 over b minus a, here's my a and here's my b. So it's 2 minus -1. Integral a to b is -1 to 2, and then of the function, which is 3x squared dx. Okay? Now, this first part here, minus a negative, is really a plus. So that's really 1 over 2 plus 1, which is the same as 3. Okay, then in here, I'm going to do the formula that we learned yesterday. So remember, you take the antiderivative first. So 3x squared, if I increase the power by 1, becomes an x cubed. Then I divide this 3 on that 3, it goes away. Remember, no plus c. Then I'm going to plug in 2 and -1. So let's plug in 2 first. We're plugging in 2 cubed, that's going to be 8. Bottom, we're plugging in -1 cubed, that's going to stay a -1. And then for the integral part of that, I'm going to do top minus bottom. So it's 8 minus -1, which comes out to be 9. If you want to keep these brackets, it doesn't matter. Usually I'll change them to parentheses once I switch. Now, this 1 over b minus a is staying in the front. So at the end, what I want is the third of 9, which is equal to 3. What that means is that that is the average of the height of the equation on the interval from -1 to 2. So let's just kind of sketch a graph, get an idea of what that means. So 3x squared, you should know what that looks like. Okay, it's a quadratic, it's pretty steep. Okay, that's y equals 3x squared. Okay, then we'll say that -1 is maybe here, and then 2 is maybe here. So here's -1, here's 2. Okay, basically what that means is that if I take the height of the function here all the way to here, and I average it out, that 3 is the average height. Okay, and that should make sense, because if you think about it, I want to have about this much of the graph under to counter this much of the graph over. That is the central y value when I add them all together. Okay, and then compute the average. Okay, so now what you are going to do, okay, I know this is super bootleg, but you get out your paper that you picked up on the way in. Okay, I am videoing these notes from home, and I forgot to bring that frickin' paper home. So, instead of me getting to write on a worksheet like you, I had to make my own worksheet in this dweeby spiral. Okay? So, you should now be on the handout. You have a worksheet. The sub was supposed to give you to this. Oops. Substitute gave you this. Okay, so make sure that you get this worksheet. It should say notes, average value versus average rate of change. Okay, at the very top of the worksheet, you should have these two definitions. Okay, they're a little bit longer on your worksheet, but you already have them in your notes. 1 over b minus a is the average y value. Okay, f of b minus f of a over b minus a is the average slope. So remember that slope and rate of change, okay, those are the same. So average rate of change and average slope are the exact same thing. Okay, so let's see how this plays out on your worksheet. Take a look at the very first example that you were given. Okay, we're looking at number 1. It lists over here that your units are in meters per minute. Forgot to copy that down. Okay, and it tells you that this is the graph of velocity. Okay, you're looking at your worksheet. I'm looking at the worksheet that I tried to make in my spiral. So part A says to find v of 8. Well, if this is a graph of velocity, and I want the velocity of 8, okay, well, if this point here is 420, then 8 would be about here. And remember that since this is a graph of velocity, okay, velocity of 8 is the y value, which is 20. Okay? Now, let's talk about units. Okay, the velocity at 8 is measured in meters per minute. Okay, because I'm looking at a graph of velocity and they asked me for velocity at 8. Now, when it says interpret the results, okay, I would say, okay, well, this is the velocity of a car. So here's my interpret. Okay, just so that you can see what that's supposed to say, I would say at t equals 8 minutes, car is traveling. Now, my velocity is positive 20, so that tells me that my car is traveling to the right at 20 meters per minute. Okay? Alright, next question, go down to part B. So it says, find the integral from 0 to 24 of v of t, then interpret the meaning of the context of the problem. So the first thing that you should know when you see this is that anytime you have an integral of velocity, you have a graph of velocity, you are computing the area of that graph. So obviously that's a trapezoid. So I'm going to do 1/2 base 1. Okay, look on your paper, count how long that is. It looks like it's 24. Plus the base on the top is from 4 to 16. So that means that this base up here is 12. And then it looks like my height here on my graph is 20. Okay, your graph looks a lot better than mine. Hopefully I did that right. So 24 plus 12 is going to be 36. I want half of 36 times 20. Okay, well, to keep that easy, half of 20 is 10. 10 times 36 is 360. Okay, now let's talk about units. Remember that when I am doing area is length times width in general. So my length is in minutes, my height is in meters per minute. And remember that when you calculate area, these minutes are going to cross out. So my result is going to be measured in meters. Now, let's interpret that. The first thing I want to point out to you is that for part A, my interpretation is at time 8. Okay, but for B, I'm over an interval. So I would say over 0 to 24 minutes. Okay, that's my time. And then I would say, okay, well, what's happening? If I'm measuring meters, meters that what? Okay, well, read the question on your paper. It says it's the meter, this is the velocity of a car. So I would say over 0 to 24 meters, the car traveled 360 meters. So when I integrate velocity, I figure out how far the car's position changed, or how far the car traveled. Okay, now the next question says I want the average value on 0 to 24. So remember, average value, I'm going to be doing the formula that you wrote in your notes. So it's 1 over b minus a, which is 24 minus 0, integral 0 to 24 of v of t. Now, remember, I already figured this part out. Okay, I just did the integral from 0 to 24. It came out to be 360 meters. So this is 360 meters. Okay, but then in the front, I have 1 over 24 minus 0 is 24, but that's measured in minutes. So my final answer here, if I have 1 over 24 multiplied by 360, I'm going to have 360 over 24, but now think about units. My meters are on the top, my minutes are back on the bottom. I'm back to meters per minute. Okay, and I want you to think about, those are the units that I already started with. But remember, this is an average value. So whenever you are finding an average value, you should have the same units as the original problem. Okay, because remember that I lose the bottom units when I do the integral, but then I get them back because of the 1 over b minus a. So if I'm meters per minute here, my average should have meters per minute as well. Okay, and then I would say I don't really have a ton of room for my interpretation, but over 0 to 24 minutes, the average velocity of the car was, okay, and then probably I can simplify this, divide 360 by 24, 360 divide by 24, that reduces to 15. Okay, so this is the same as 15 meters per minute. Okay, and that would be your interpretation. Okay? But remember, average value, my answer should still come out as meters per minute. Now, let's talk about v prime of 8. Okay, v prime, this is going to require us to take the slope at time 8. Okay, v prime is going to require me to take the slope at time 8. Now, look at your graph. Here's 4, here's 16. That means 8 is somewhere in between on your graph. Okay, and if I want the slope of the graph at that point, well, look at the slope. It's flat across. That means that that is a slope of 0. Now, let's talk about units. If this is meters per minute, then the derivative should be 0 meters per minute squared. And what you should think about is that if velocity's slope is 0, that means that I have a constant velocity at that moment. Okay, velocity is constant at t equals 8. Now, not only is it constant at 8, but if you look at your graph, it's flat all the way from 4 to 16. So this entire part of the graph, my velocity is 20, staying right there at 20. The car is going 20 miles per hour the whole time. Okay? The other average that you need to know how to do is average rate of change. So remember, average rate of change is also a slope, but I'll be using this formula right here, f of b minus f of a over b minus a. So I'll do v of 16 minus v of 0 over 16 minus 0. Then I'll look at my chart. 16, the y value is 20. 0, the y value is 0. 16 minus 20 is 16. So I get 20 over 16, which can reduce. Okay, 20 and 16 can both divide by 4, so that will be 5 over 4. Now let's talk about units. Average rate of change, that's a slope. And so if my original was meters per minute, then the slope of that would be measured in meters per per minute squared. Okay? Okay, and then remember, let's talk about just real quick the difference between the two things here. V prime of 8 tells me the exact rate that my velocity is changing at 8, which as we said is 0 because it's not changing. But average rate of change 0 to 16 means that on this part, my velocity was increasing. On this part, it was 0. But if I were to compute the average of those two things from here to here, okay, that would be my average slope or average rate of change. So I would be averaging the steepness of this line with the steepness of that line. Okay? Alright, pause it if you need to, then turn the page. We're going on to the next example. Okay. So your next example, take a look at number 2. Okay, very poorly drawn on my own paper here. First thing it asks me to find is A of 7. Okay, well, this is a graph of A. So if I want A of 7 is right here. Okay, remember, this is an acceleration graph, which is stated already on your paper. So A of 7 here is 0. Now, let's talk about units. This is a graph of acceleration. So when I plug in 7, I'd get miles per hour per minute. Now, that's kind of a weird unit for acceleration, but it still is possible. Because remember, I normally would have like meters per minute squared, but this time, it's miles per hour per minute. So all that means is that I have two distinct time units. Instead of it being minutes per minute squared, it's like hours per minute. Okay? So include units in your answer. I would keep them the same as the original question. Okay, next I want A of 8. 8 would be here. And looking at my graph, it looks like that's at a height of -1. So I would say A of 8 is -1 miles per hour per minute. Okay, now for interpret on this one, I would say at time, t equals, that'd be 8 minutes, because that's what I'm measuring on the x-axis here. And then remember that acceleration is telling me how velocity is changing. If acceleration is negative, then I know that velocity was decreasing. So I would put at time t equals 8, velocity is decreasing 1 mile per hour each minute. Okay, at time 8, my velocity is decreasing because of the negative 1 mile per hour each minute. Now, I forgot to do that on part A, so let's write that in. At time t equals 7, my velocity, if its rate of change is 0, is staying constant. Okay, not changing. It's not increasing or decreasing. Okay, acceleration is 0, means that my velocity is staying exactly the same. Versus when velocity is positive, when acceleration is positive, velocity is increasing. When acceleration is negative, velocity is decreasing. Okay, next one, I want to integrate from 0 to 9. Okay, well remember, anytime that you see an integral like that, that should tell you that we're going to be computing the area. So I notice that up top I have a big trapezoid. Okay, area of this is all going to be considered positive. So I'll do 1/2. My base on bottom is 7 units. My base on top is 3 units. 7 plus 3 gives me 10. And then I have a height here of 4 units. Okay? So that'd be 1/2. 7 plus 3 is 10, times 4 is 40, cut in half is 20. So that area in there is 20, but then I also have this little area down here below. So for that, I'll do 1/2 base, which is 2, times height, which is 2. Half of 2 times 2 is 2 again. Now, keep in mind that when I'm computing an integral, I need to consider whether the area was above or below. So I would say I had positive 20 units, but then I lost 2 units. That's a total of 18. Now, let's talk about our measurement of time. Whenever I do area, I would do my y units multiplied by my x units. So that would be minutes multiplied by miles per hour per minute. Okay, and then think about what's going to happen. If I multiply minutes times miles per hour per minute, these guys are going to cross out, and I'm going to get 18 miles per hour. Okay, now it does say to interpret that, so let's think about when I integrate the graph of acceleration. Okay, the integral of acceleration is velocity. So this tells me how much the velocity changed over that time period. So let's do our interpret. So I would say over 0 to 9 minutes. The integral of acceleration is called velocity. Okay, then I would wonder, did it increase or decrease? Well, 18 is positive, so my velocity increased by 18 miles per hour. Okay, and remember that miles per hour is just like meters per second, feet per minute, anything like that. MPH is just a different abbreviation. If you wanted to write it like this, okay, to make it look more like a unit of velocity, that's totally fine with me. Okay, next question. I want the average value of the function. Okay, so average value of the function is going to be the formula that you just learned. 1 over b minus a is 9 minus 0, integral 0 to 9, a of t dt. Okay, but then remember, I already figured out this integral. I'm not going to do that again. Okay, the integral from 0 to 9 came out to be 18. We literally just worked that and got 18. So this part here is going to be 1/9 of 18, which is the same as 18 divided by 9, which is equal to 2. Now, you'll notice on your worksheet that it says to include units. So, remember what I said. Average value is always going to have the same units as the original problem. So, look up here. What were my original units? Miles per hour per minute. Then miles per hour per minute is going to be the exact same units for average value. Okay? Alright, last question. Part E says, given the velocity at 0 is 10, find the velocity at 9. So look at your little paper, it should say that. So I want to find the velocity of the car at 9. So first thing that I notice is they're telling me the velocity at 0. Okay, so at time 0, the velocity is 10. That's what's given to me. Now, remember, what did they give me a graph of? They gave me a graph of acceleration. So, if I want velocity, what's the relationship between acceleration's graph and velocity? Well, velocity is the integral of acceleration, right? So I'm going to look at my graph, find my critical numbers. So come back up, take a look at your graph. The only critical number I see here is 7, and then my end point here is 9. So 0, 7, and 9 go in my chart. And then think about, my velocity started at 10, and then I'm going to come up to my graph and see how much it changed. Over the time from 0 to 7 here, my velocity increased by this amount of area. So if it increased 20, 10 plus 20 more means my velocity is now 30. Okay, then I'll do the same thing over the interval from 7 to 9. From 7 to 9 here, my particle lost 2 units. So if it was at 30 and it went down 2 because it lost 2 units of area, then its final velocity is 28. Okay? Now, keep in mind that whenever I do area, okay, remember what we said, we're multiplying, okay, when we're integrating area, or integrating acceleration, it's minutes times miles per hour per minute. Those guys cross out, miles per hour is the answer. So I would say at time 9, measured in minutes, the velocity of the car is 28 miles per hour. Okay, but remember that the per minute is gone from when I did the integral here, and I canceled those guys out. Okay? Alright, almost done. We are not going to finish the packet today. We're going to do one more page, and then we're going to call it quits. We'll finish up tomorrow. So, turn the page if you will, please. Okay, we got 2 more left on this next page, and then you'll have the rest of the class to work on your homework. So, number 3, we're talking about a substance. Okay, it says the substance is decaying at a rate of A of t equals 1 over t grams per minute. Find the integral from 4 to 12 of A of t. Okay, well, the first thing that I'm going to do is say, okay, 4 to 12. Acceleration is 1 over t. And actually, I guess it's not really acceleration because it's how fast it's decaying. So, integral of 1 over t dt. Okay, well, hopefully you remember the integral of 1 over t is ln, absolute value t. Then I'm going to plug in capital F of 12, capital F of 4. Plugging in 12 first, I have the ln of 12. 4 second, I get the ln of 4. But then remember, whenever I'm doing fundamental theorem, I take these two values and I subtract. So I have the ln of 12 minus the ln of 4. And then we learned yesterday that whenever you're subtracting logs, you can divide the arguments. So I'll do 12 divided by 4. And 12 divided by 4 is ln 3. Okay? Then it says, interpret the meaning in the context of the problem. It says that on your paper. So remember that when I do an integral, okay, an integral is area, and area is going to be length times width, or grams per minute multiplied by minutes. Okay, well then what's going to happen? Okay, my minutes are going to cancel out, and I'm going to get what? The number of grams. Number of grams of what? The number of grams of substance that decayed. Okay? So, for my interpretation, which it asks you to do on your paper, you would say over t equals 4 to 12 minutes ln 3 grams of substance decayed. Now, if you have a calculator, you can figure out what the ln of 3 is, but we know that it is a number of grams. How do we know it's a number of grams? Because grams per minute times minutes equals grams. Okay, the minutes cross out just like they did right here. Okay, well then the average value, okay, will be 1 over 12 minus 4, integral 4 to 12 of A of t dt. But remember, I literally just did this. Okay, so I'm going to look up here when I did the integral from 4 to 12. Okay, 4 to 12 came out to be the ln of 3. So the only thing I really need to put in front of this is this guy right here. Okay, 12 minus 4 gives me 8. So it's an 8th ln 3. Okay, now let's talk about what that stands for. Okay, so if I were to take my 1/8 ln 3, okay, you can type it into the calculator, turn it into a number. Remember that average value, you keep the units the same. So A of t was originally measured in grams per minute, then the average value is still measured in grams per minute. Okay? Alright, last one we're doing together. Take a look at number, and actually does it tell us to Yes, it says to interpret, so I would say over T equals 4 to 12 minutes. Substance average rate of decay is an eighth ln3 grams per minute. Okay, so if this is the rate that the substance was decaying, then this is just the average rate that the substance is decaying, because it's a y value. It's measuring the same thing, it's just measuring the average. Okay? Alright, and then actually we're going to stop here. So, we will pick up at this point tomorrow. Okay, on Friday you will have a quiz over all of your stuff. Keep in mind Friday is also a pep rally day. So if we have time tomorrow, I'll go ahead and give it to you early. But make sure that you get some work done on homework 6. That is due on Friday as well. Okay, also if you take a look at the back of your homework 6, now you can do the rest of those questions. Okay, good luck. You can do it.